Now that we've taken a look at some of the basics of creating mates, moving parts, and some of the fundamentals of creating assemblies, let's go through an exercise where we put together a simple assembly like this one here, discuss some assembly tools, and take a look at how to create motion. Let's start with a new assembly file. And bring in the first component. The part we'll be using already exists, so I'll use the Browse option. The part I want is this one called Outer Cover. At this point, I can just click and the part will be dropped into the assembly wherever I happen to click. Rather than doing that, I'd like to drop the part on the origin of the assembly. Of course, this isn't a requirement, but it does make things easier when the first component is located at the center of the assembly. Since I can't see the origin of this assembly, I can go to the View drop-down menu and select Origins. And both the part origin and assembly origin are now visible. I'll move my cursor over the assembly origin, click, and the part locks into place. Another nice reason for dropping components on the origin is that the part's origin is aligned with the assembly origin. This means that if I open this part and look at the front, top, right, and isometric views, they are the same as the front, top, right, and isometric views of the assembly. Next, let's bring in the second component, called Inner Cover. This component can be dropped anywhere in the assembly, since we will be using mates to position it properly. Before we do that, let's take a quick look at the Feature Manager tree. You can see the two components listed. The first one with an F in front of the component name, indicating it is fixed in space. If I click on the part and attempt to move it, SOLIDWORKS will tell me very nicely that I can't. On the other hand, this inner cover has a minus sign in front of it in the Feature Manager tree. As we've learned, this means that its position is underdefined. You can see that the component is free to move and rotate freely. As you saw in the completed example, we do want the inner case to be able to move, but not this freely. We need to add mates to lock down some of the degrees of freedom. The first mate we will create is between this pin and this hole. I'll add a mate and select this face and this face. Remember, you might need to use the aligned or anti-aligned option. The next thing we need to do is center this inner cover inside of the outer cover to keep it from moving side to side. You can see that we're going to end up with small gaps on either side. If we knew the sizes of the gaps, we could use a distance mate to establish the proper distance from this face to this face, which would effectively center the part. Well, there's a problem with this approach. What if later the overall width of the outer cover changes? Will the part still be centered? Well, not unless we come back and adjust the distance mate here. So this approach is not a very good one. Instead, we can use the part's default planes to center these parts. Here's how. I'll use a mate and click the banner up here to reveal the Feature Manager tree. From the tree, I can expand the features of the outer cover. And just by moving my cursor up and down, you will see the front, top, and right reference planes highlight. This makes it easy to select a plane that runs down the center of the part, which is the right plane. Next, I can do the same with the inner cover and select its right plane. Now I can use a coincident mate and make certain the parts are centered. As a side note, the only reason the right planes of these parts are located conveniently in the center is because of the way they were designed, And in general, it is a good idea to try and design your parts like this whenever possible. If you are ever faced with a challenge of centering two parts like this, and you aren't lucky enough to have planes in the center, you can always go back to each part and create the planes yourself. With the last mate we added, you can see that the only motion left is the motion we were looking for from the beginning. In this next couple of lessons, we'll take a look at how to analyze this motion and make sure that there aren't any collisions or interferences in the mechanism.